Hey to Dr. Shukri and to my fellow friends. My name is Satya Vasagan, and my metric card number is CD220209. So today I want to talk about the introduction of the thick cylinder. So nuclear power infrastructure, the chemical and petroleum industries, and the military all make extensive use of thick wall cylinders. High pressure and temperature, which might be constant or fluctuating, are typically applied to them. Due to discontinuous in geometry or property or the material ductile fracture of material is frequently observed in industrial problem. The internal pressure up to the material yield strength can be determined using the standard elastic analysis of thick wall cylinders to final radial and hoop stresses. In this project, strain gauges mounted on various radius at a different alignment throughout the cylinder wall provide the opportunity for students to measure the strains and hence strain distribution throughout the wall of a cylinder subjected to an international internal pressure. Thank you. Okay, secondly, I want to talk about the objective of this thick cylinder group report. So the main objective of this experiment is to demonstrate and analyze the stress system in a thick cylinder. Other than that, to study the distribution of stress and strain in a thick wall cylinder beneath internal pressure. By applying the above equations for calculating matching stress value, the experiment seeks to compare the measured strain level to theoretical expectation to evaluate the precise of the theoretical models and confirm the connection between stress, strain, and internal pressure in thick wall cylinders. The calculated and theoretical stress value are examined. It also helps in comprehending how material behave under pressure and confirming that stress strain equation are applicable to real world engineering application. Thank you.
Good day to Dr. Spree and my classmates. My name is Loga Ganeshan. My matrix number is CD220032. Now I'm going to present about the experimental design and apparatus of the lab experiment thick cylinder for a group project. So firstly, we are going to see about the experimental design. So this is the experimental setup, which is computerized thick cylinder experimental arrangement and strain gauge positioning. And the real image of the lab setup has been added to the lab report for your information. So now we are going to look at the two experimental criteria which we have used in the lab report. So firstly, the location of the strain gauges. So the table has been added to the left side on the slide, and at the top side of the slide is the technical information of the experimental setup. So the list of the apparatus for this lab report is firstly cylinder, strain gauges, hand wheel, and the most important one SM1011 software. Next is experimental procedure for the report. So firstly, we have to prepare the cylinder. We have to ensure the cylinder is zero pressure. Second, set up the software. Select zero readings on the software to zero the pressure and strain signals. Thirdly, adjust the pressure. Increase the pressure to the desired value, the value that we need. Fourthly, record the data. Next, calculate theoretical strain. Record all measured and theoretical strain values. Derive stress from measured strain. Use these measured strain values from the experiment. Calculate the theoretical stress. And finally, record the result. Use the theoretical stress to calculate stress. Thank you.
My name is Norahadatul Ashminti Azlan. For the calculation, this is the calculation of strain based on the formula and the radius in the table. Next, this is the calculation of stress and derived stress. Also, the calculation for the theoretical value based on the formula. As for the graph, there are four graphs to compare the experimental result with theoretical values, which is graph of hoop against 1 over r square, derived and theoretical, and graph of radial stress against 1 over r square, derived and theoretical. For discussion of the result, the stress distributed analysis in thick wall cylinders shows expected trends in both theoretical and experimental results. Hoop stress increases while radial stress decreases as the cylinder's radius grows. Following the fundamental principle of stress distributed, however, a discrepancy between theoretical and experimental results suggests measurements error, possibly due to human error or equipment inaccuracies. Thick wall cylinders are widely used in industries like metallurgy, air compressor, hydraulic system, gas storage, and hot water tank. Due to their ability to handle high pressures, their reliability makes them vital in both industrial and domestic application where safety and performance are crucial. For observation, the experiment's finding align with the principle of solid mechanics. Radial stress was highest at the inner surface and decreased to zero at the outer surface, while hoop stress peaked near the inner surface and diminished outwards. As expected, the inner surface also experienced greater strain due to higher stress. At high pressures, a slight deviation from linear elastic behavior was observed, indicating the start of non-linear in the material response. Thicker cylinders show a more evenly distributed stress compared to the thinner ones, where stress concentrated near the inner surface, with small discrepancies attributed to material imperfections and experimental errors. The expected radial and hoop stresses increase with internal pressure. The absence of the sudden failure suggests the material can safely handle with the applied stresses within its design limits.
Hi, good day to Dr. Shukri and good day to everyone. My name is Sanjay Faraj in CAD Matrix CD220112. Today I'm going to explain about a conclusion, which is what we did for our project. The experiment goals of investigating and demonstrating the stress system in a thick cylinder were accomplished. It validated the accuracy of derived stress calculation and the shed light on how stress and strain distribution behave in the thick wall cylinder under a pressure. Although differences, we observe that most of the result of the procedure or human error, the theoretical and experiment comparison of hoop and radial strain show an anticipated trends. Notwithstanding these difficulties, the information gathered successfully advanced knowledge of thick cylinder mechanics concept and identify important areas for further improvement. However, this experiment also teach us more about thick walls and the derivation of stress equation. Thank you. Hi, good day to Dr. Shukri and good day to everyone. My name is Sanjay Faraj, Matrix CD220112. Here I'm going to explain about a recommendation for the improvements. First of all, the ensure the appropriate equipment's upkeeping. Before starting the process, make sure all the experiment are set in good and in working order. Second point, which is we call boost the accuracy of data collection, which is reduce manual reading errors by utilizing automated methods or digital tools. Moreover, improve the method of experiment, which is measure should include redundancy to cross-check important information. And the fourth point is enhance the surrounding to reduce outside influence like temperature swing that could alter the material's characteristic and outcomes to do the experiment in control settings. Besides, using cutting edge analytic tools, which will cross check experiment, which result with a true theoretical study using simulation tools. Moreover, source of document errors, which is to help understanding inconsistency, keep true record of all possible error sources, such as departure from established practice and outside influences. And lastly, promote peer review, which is establish the cooperative review procedures to find any missing information. These were the few important and recommendation for the improvement for our project to use the tools and the investigation for it. Thank you.